Okie dokie. So this is the third part of the 6-part series. We're going to be introducing you to general operations and the tool table. So let's start off with the tool table. You can see here that in the cloud, which is what you guys are gonna be using. Somebody will set up the new tool table. By the time you're viewing this video, you probably won't be referring to this. You'll have the new Haas mill, and with the new Haas mill, we only have so many things that we can use. But luckily for you guys, there should be an updated table that somebody else already made. But generally speaking, this is the actual tool table itself for your parts. So this will go ahead and list all the tools that you've used, and say you actually. So right now, I'm not actually using this tool. Tool 11, 1/2-inch roughing end mill. I'm not using this tool. So say you have a bunch of tools that are populated, and maybe you did an operation and figured out, oh shoot, I actually don't really need to use that tool. It'll still show up here. So in order to clean your tool table, you just click this little sweeper at the top, and you remove that basically all the unused tools, and that'll just make it really nice and organized. So that way, whenever you come back to doing so, when you ever reference this tool table, say you're making your tool list, you're prepping your tools for the mill, you have a nice clean tool table that you can reference. Okay, so that's pretty much it for the tool table. I'm not gonna go into the organization of it and all that, but I will hit a couple of key points actually. So we have, generally speaking, our end mills. We have end mills and we have drills, and then we have a few specialty tools, like chamfer tool and engraver tool. You have like face mills, like the fly cutter, the dodeca. But within the end mills, we have a couple categories. So we got our flat end mills, both for finishing and roughing. Finishing is for taking off like small layers, possibly even bigger layers if you don't have a roughing end mill. Your roughing end mill is what you're going to be using most of the time. It's really, it's what you use. It basically has teeth, and that allows it to make partial tool engagement, allowing you to take a larger depth of cut when controlling it. And you control that within optimal load within adaptive clears. I'll show you that in a little bit. You have bullnose end mills. Bullnose end mills are really solid for like if you design a part and you need really like just tiny little fillets. It's basically a flat end mill with tiny little radiuses. Sometimes those radiuses are so small that if you look at the actual end mill itself, you might actually confuse it for a flat end mill. I've definitely done that, but in the end, generally speaking, if you do that, it's really no harm, no foul. If you have like any sharp corners and you hit it with that, you're just reducing the amount of stress concentrations that you have in your component. And then you have your ball end mill. Ball end mills are really good if you have like a ramp section in your part. You need to use parallels. Hopefully you don't need to use parallels yet. If you're watching this video, I mean, this is just a really, really basic introduction to this stuff. So yeah, talk to somebody with more experience than you if you have to use a ball nose end mill. But it's really good for doing fillets. When you're designing your part, if you standardize your fillet sizes, for instance, if I have a 1/2-inch fillet on my part, I can actually come in with a 1/2-inch ball nose end mill and just do a nice little contour, and it'll basically leave a really beautiful surface finish. Otherwise, if you have an unstandardized fillet, you'll have to use like an operation like parallels or something, which can be quite annoying, and it could take a lot longer compared to just a contour with a standardized radius. Okay, I think that's it for tools. So let's go ahead and talk about operations. So there's a couple different sections. There's 2D and there's 3D. If you find yourself using more operations than others, you can go ahead and say, for instance, I like to use this flat one a lot, which I never actually like to use. You can actually pin this to the toolbar to ensure that you have better access. But you know what? I don't really use flat that much. I'm going to take that off the toolbar. Yeah. Okay. So you have 2D and 3D. You kind of know how to, if you want to pin stuff up here, that's cool. And really useful. But let's go ahead and talk about 2D versus 3D. 2D you typically want to do if you have, if you want to control your end mill to a specific area, if you have like sketches that you're using to define the area that you're machining, all that stuff. But I don't really use 2Ds that much anymore. Really, the bread and butter of what we do is we're going to be using adaptive clears. Adaptive clears are super useful. It does all the work for you. And there's a couple constraints about it, but you generally speaking, you just let it rip. You have to change a few parameters, but it's pretty automated, which is really nice. So breaking this down, 2D and 3D aside, you have two primary tool paths that let's disregard drilling. You have two primary like tool paths that you're going to be using, two operations. You're going to be using roughing passes and you're going to be using finishing passes. So if you're new to machining, roughing passes are tool paths that go extremely fast. Oh, extreme is a rough way to put it, but they're fast tool paths that remove as much material as possible. But what happens is they leave a small layer of stock, and then once we get the component down to almost naked form, we just come in with either with our finishing passes that go nice and slow, and they leave a beautiful surface finish. So that way we have a nice looking part and a part that is up to the spec that we designed it for. Typically, roughing passes, we're going to be using adaptive clears. Actually, really, in all roughing passes, you're going to be using adaptive clears. And then for finishing passes, we have two areas that we want to finish. We have the axial, like we have finishing in the axial areas. So when I say axial, I mean these flat faces. Looking at the origin, we can see that we're looking down at the part right here. You're probably going to be looking at the part like this when it's in the vise and you're looking at the mill, like from an ISO view. But you have your axial finishes and your radial finishes. So whenever you hear me referring to that, radial is basically the side of the tool, wherever the side of the tool touches, and then axial is where the bottom of the tool touches. So whenever I refer to that, just remember that that's what it means. But we have two different surface finishes, surface types. So yeah, with our radial surfaces, we're going to be using contours typically. And then for our axial surfaces, we're going to be using pocket. Now the advantage of the roughing pass is of course that it's faster, but there are some concerns to take, especially when we're talking about the roughing end mill. So let's go ahead and do our first thing. Thingamabobber. So we're going to use the 1/2" end mill. You guys will have a new tool library, so most likely. So we're going to click OK. And now something's going to come up, and I'm going to point that out to you right now. What's happening in this adaptive clear is that it's going pretty much all the way to the bottom. It's finishing this all the way to here, which is fine sometimes. But here's the concern. This part is in the vise, and it's most likely, if we look at the setup, it's going to be clamps like below this line, of course. And if we actually do that adaptive, it'll actually hit the vise itself, which is not good. We do not want that. That is no bueno. So how we actually control where our adaptives go is we go to heights, and then we change our selection to here. If you're using the second to last parallel, you want a clearance of second to last parallels with the 6" vise that we have now. It's about a clearance. It's gripping 250 thou. So generally speaking, I always want to make sure that I have about 300 thou of clearance. So if we simulate that, that's awesome, but there still is another problem. Because I have stock to leave and I change my bottom height to just the very bottom of this part, it's not actually exposing it to this line. It's exposing it a little bit above it. Because if you look here, if you go to my settings, you go to passes under the adaptive, you see that I have an axial stock to leave of 5 thou. So there's a layer that's 5 thou above this bottom section. So in order to fix that, I'm just going to come here and I'm going to change this offset. Let's go 50 thou. That should be more than enough, especially if your Z heights are, you measured your Z really accurately. A lot of the times you can't get your X and Y with calipers, but you can get your Z. We don't have ridiculously tall pieces of stock. So yeah. Now that that's machined, a quick trick that I want to show you that I've been using for a long time is, in order to do a sanity check, and I know, like, obviously looking at this, I know that this is more than 250 thou of clearance, or sorry, 250 thou, which is the amount the vise is grabbing if you're using the second to last parallels, but at least I want at least 300 thou of clearance. So A sanity check that you can do is be like, okay, well, I saw where that stopped, and in order to meet my minimum clearance requirements, I can actually change this to stock bottom, and then I could change this to 300 thou. And so this, I know for sure, will clear my vice as long as you measure your stock correctly in the Z. I know that this will clear my vice, and this is really useful to sanity check yourself if you have like particularly a really short piece of stock in the Z direction. But that's not really needed here, so I'm going to go back and change the heights to model bottom with an offset of -50 thou. Oops, not model bottom. I was capping selection, that guy. Yeah, with an offset of -50 thou. Boom. Okay. So with the roughing end mill, this is super important, specifically with the roughing end mill, just because of the surface finish it leaves. For the radial stock to leave, and this might change if the roughing end mill is 1 inch in diameter, but this is what it is for now. Stock to leave, you want about 10 thou, and then the axial stock to leave 5 thou. So we'll call it good. Optimal load is last thing to cover with the adaptive is your optimal load. Now, what makes the optimal load, the adaptive clear different from pretty much all the other stuff is that you actually have this parameter, optimal load. And, you know, if you want, you can go ahead and pull it up yourself on Fusion. You could read what it does, but it just really controls the amount of tool engagement that you have in the entirety of the tool path. Now there's kind of pseudo ways that you can do this with like contours or something by adjusting the step over. But really, this is the most reliable way to control your tool engagement when you're hogging away a ton of material. So the advantage of the roughing end mill is that we can go up in optimal load. A good practice to think about optimal load is if you get the tool's diameter and you get 25% of that tool's diameter. For instance, say this was a 1/4 inch end mill. Okay, 1/4 inch end mill. 0.25, and then we get 25% of that, 0.25. That equals 0.0625. So we can change our optimal load to 0.0625. And that's going to be a not really, but it's going to be a generally kind of conservative. It's a pretty good mid ground for your optimal load. Not too little, not too much. And you don't want to be on the super conservative end when you're doing this stuff, because it will increase your machining time by a good margin if you're doing that. So that's the last thing to cover over adaptives. Machining boundaries and stuff, you guys won't really need that until you get more advanced, hopefully, depending on your part. And if there is a part, hopefully your lead can kind of explain it to you, how to control machining boundaries. But I typically do it with sketches. You go to design, you do a sketch, and then you have a box. And then with that box, let's just pretend that I did a sketch. Actually, you know, I got it. So let's go over to this guy. I think, yeah, this guy. So you'll notice that, let's look at this adaptive. Ooh, no, that's not a good example. No, that's not a good, maybe this might have not have been a good example. Yeah, I was capping. This ain't a good example. Whatever. Machining boundaries, good for making sure that you avoid the vice. Wait, let's, for the sake of time. Okay, cool. This one looks solid. Okay. So I'm gonna go ahead and simulate this. And now when looking at this part, oh shoot, this one might kind of suck too. Here, let's check this. Models, bodies. I'm just here to control my bodies. Okay. Oh yeah. So here I have this machining boundary selected because this part is getting gripped by the vise from the outside, and I don't want it to exceed this area itself. If it exceeds this, it's going to hit into the vise. So I'm just controlling the actual adaptive itself in order to ensure that, you know, we're meeting all of our clearance requirements when it's clamped to the vise. That probably wasn't a very good explanation, but oh well, you'll figure it out. Okay, let's go into our finishing passes. Pockets. the cool thing about the roughing end mill is even though the radial portion of the roughing end mill is rough, the axial portion isn't. So that way we don't actually have to waste time doing a tool swap. With the Haas, it'll be automatic, but for our machine right now, it does take a bit of time to actually swap tools. It has to go back up to its home position. You have to take out the tool. You have to manually put in a new one, and it has to go all the way back down to start machining again. So axial faces. This is a 2D, so you actually do have to make selections when in regard whereas the 3D adaptive, you just click, basically you change the parameters. You click OK. It'll do it. This with 2D stuff, you have to actually select areas. So let's go ahead and do our finishing passes, and let's see how that does. I'm going to select all the axial regions. It probably won't be able to get every single region. Yeah, so we're getting an error here, and that's totally fine. So it's just going to go through and it's going to clear all this stuff. And you'll notice here that this area isn't actually clear. There's still stuff that we have to clear. So what that means, so that's not good. So we just did right here, it just actually did a clearing with a pocket, and we're not able to control tool engagement so much with a pocket. So it might come in too fast and just is taking away too much material at a time. And that is not good. But for the sake of time, we'll go ahead and just continue on. Just a quick note, for this, we're not going to be able to use the roughing end mill, unfortunate. So what we actually have to do is we actually have to do another adaptive, but instead we need to use a smaller tool size because the 1/2 inch end mill, unfortunately, isn't able to get into this tight space. Let's see what the distance is between this. So that's 0.352, the distance between these 2 points. So the half inch end mill can't even fit in between this space. So we definitely have to step down our tool size to a smaller flat end mill to ensure that we're doing that correctly and using the adapters properly. Okay, so last part that I want to cover. I know this is a pretty long section. I'm trying to move fast. Contours. Contours are radial finishing passes. Cool. So what we're gonna do is we're actually gonna go and select. This is the roughing end mill. I don't want that. I'm gonna step down my tool size. Let's do it at 3/8. And this isn't gonna apply to everything because I designed this kind of badly, unfortunately, and I probably won't be able to hit everything with a 3/8. But we're gonna select OK. And now, because this is a 2D, again, we have to select our geometry. So I'm gonna select this geometry. I'm gonna select as much as I can. This geometry. Oof, not good. So yeah, that's obviously not going to work because if we do this pass, it'll basically take out this entire middle section. So no bueno. Let's delete that one. Boom, boom, boom. And like I said, this won't be able to hit everything. Yeah, we're gonna have to control a lot of this with sketches, which is fine. But let's go ahead and show you guys what it does. Oh yeah, and another thing to note is that you can actually, when looking at the geometry, you can control the side by clicking this little arrow here. Ah, bollocks. Okay, that thing is, oh, got it. Okay, yeah, so you can actually change which side the tool is running on. Super important, especially when you're chamfering, to pay attention to that stuff. You don't want to be hogging out huge portions of your stuff. Let's just go ahead and do that and show you what it does. Oh, no, Fusion is smart enough to basically say, nah, I ain't gonna do that because I'm gonna destroy your part. But in terms of roughing and finishing passes, that's the basics. I'm gonna go ahead and do the rest. I'm gonna do some mining off camera, and I'll come back to you guys and show you the rest of it. Before I actually move on, I'm gonna show you something that I really wanted to point out. So I just said, when doing this contour, let's go back to the 3/8. When doing this contour, when we select our geometry, it's selected this entire portion, which I don't want. Let's see what it does. So it'll actually go through and murder all of your part. So you see your part is destroyed. Unfortunate. Now how we control that, as I previously mentioned, is sketches. Sketches are OP. They need to nerf them. So let's go ahead and start a sketch on this face. There's some things that Fusion does better. There's something that SolidWorks does better. You'll notice that it can be wonky. Convert entities is so project entities is the equivalent of convert entities. They work a little bit differently in Fusion. They could be like I said, a bit wonky at the times, but we're gonna go ahead and select that. Select that. We're gonna click OK, and let's go ahead and create a line and select these 2 points. Connect it all together, and now we have a nice sketch that we can use to define the toolpath of the contour. So contour. And then we're going to select our geometry. We have this geometry that destroyed our part. And now you'll notice, okay, like I said before, you got to pay attention to this guy. Let's see what happens when it does this. Let's see if it'll even let us do it. Yeah, it does. Cool. So you'll notice that when I come down, boom, it just murders your part. That is not good. You don't want that. So we're going to go ahead and select the opposing direction. So now let's go ahead and replay that. Cool. But not cool at the same time. So the reason I say not cool is because what's actually happening when we're doing this is the very bottom of the tool is actually contacting, oh, actually, nah, we good. Okay, cool. When you're doing your contours and stuff, typically you don't want it to contact. Sometimes it's unavoidable. Say we do, let's change this up a bit. Sometimes it's unavoidable in situations like this, where if I select the geometry and we'll select this guy, of course, like it's going to be the axial face of the tool is going to be making contact, which is fine. It's not a biggie. No harm, no foul. Okay. That's all I wanted to show you for that. I'm going to do some mining off camera, and then I'll come back and I'll show you more of what's happening. Okay, so another thing I wanted to point out. So I actually came in here with Tool 30, and I'm doing I'm doing another adaptive clear. And the thing is, because this is a finishing end mill, I have less stock to leave. Now, what does that mean? That means if I do a 3D adaptive clear, I have my 5 thou stock to leave. For finishing end mills, I use 5 thou for my stock to leave. It's not as rough as obviously the roughing end mill, so I can have a smaller surface on that radial end. So what that means is when I generate this tool path, it'll want to remachine everything, because it's going to try to get everything down to that 10 thou stock to leave, which I don't want. It's going to be a lot of unnecessary time for something that I could just do with a finishing pass. So what I did was I actually created a sketch, and that sketch, I just went here to geometry, I went to selection, and I selected that sketch. And now, because I'm not really worried about my vise so much, it just says tool outside boundary. What that means is it'll just, and no, it doesn't mean what you think it means. It's not, oh yeah, tool machine everything but this inner circle. No, it means the radial end of the tool will basically go no further than, it'll always at the farthest at least still be touching this boundary, which is kind of weird. I think it should machine everything but that. You can just do the exact opposite, tool inside boundary, which does mean that it won't exceed this boundary at all. So yeah, click OK. And I'm just going through and clearing all of this, just because the 1/2 inch end mill isn't small enough to actually get into all those grooves. And you'll notice that with my adaptive clear, my optimal load, it's using that parameter that I talked about earlier. 25% of a 1/4 inch tool is 0.06, and I believe that is it for this. Come back later. Back again. So I'm just continuing to do my adaptive clears to remove as much material as possible, as quickly as possible. Just one thing I wanted to point out. So looking at this adaptive, you'll notice that it starts ramping really, really high above the part. You don't really want that. That's wasting a ton of time. And machining time is very precious. You don't want to be there forever. So like previously stated, the way you control where your adaptive goes is through the use of the heights tab, as well as like machining boundaries. So all we're going to do is we're going to go to heights, and then we're going to just change that stock height to our selection. Sorry, our top height to selection. I'm just going to select that face. And that will ensure that the ramping doesn't go all the way down. Another thing that I just saw now is that it's going all the way to the bottom of the model. We don't want that. Again, I'm gonna go here, and like per usual, I'm just gonna go below -50 thou. Alrighty. I am back again. Another thing I wanted to point out. Here I have an actual, because of how this radius is broken up into like two different sections, I just defined it with a sketch. But here I've run into a problem. So right now, my contour is actually going to be cutting into my part, and I can't select it. Oh, crap. Let's delete that. I can't select it. So one trick to do in order to select it is you just go and hide models. That's at the left here. There's a little eyeball icon. Hide it. Switch that to the inside. Show your model back, and you're good. Alrighty, ladies and gentlemen. So I have this first side complete. Let's go through all the cam. Wait, so we first initially have our adaptive clear. This is our most extensive operation in terms of the length of it. So this one, the adaptive is about 10 minutes, 10 to 12 minutes, something like that. Then while we're still, that's just that little, these boogies are just from like the accuracy on here. So in reality, it's not actually like that. It's just that our cam accuracy is down just so it plays nice and fast. While we still have this tool loaded, remember that we can do axial finishing passes with the roughing end mill. It's totally fine. And something notable is that if you look at the left side, you'll notice that all my same tools are grouped together. You might not always be able to do this, but it's just really nice because you can actually just ensure that you're not changing tools super often. You don't want to order them. You want to order them as efficiently as possible to reduce machining time. So let's keep going with that. So after this operation, that's all of the stuff for tool 11. Okay. Now I'm going to go through and I'm going to do some spot drilling in all the spots that I see fit. So this spot's interesting. I'll show you guys why in a second. Oh, shoot. Okay. We're going to spot drill that. And that's just spot drilling is just there to, I don't always do it, but I just, it's good to prevent the actual drill from walking. And then I come in here with this drill. And now the reason I'm coming in here with this drill is because I don't really have any end mills that are small enough to actually like get down in there. When you change the optimal load, sometimes when you reduce the optimal load, sometimes it doesn't actually allow you to ramp down into a tiny pocket like that. So now I just drilled that out so that way I can come back and clean that later with this next end mill that I have. So I'll come in with the 1/4 inch end mill, and now we're just doing another adaptive clear. Boom. It's gonna keep going. It's gonna get all this good stuff. This is another pretty long one. Go through and just take away all that material. And then there should be, oh, it's still going. Still going. Still the same one. And then we'll come over here to this other adaptive. Go all the way. So something notable is when I'm doing these adaptive clears, I'm actually going just below the bottom of the part because the intention is that I'm going to actually origin off of this circle when I do the part flip. So we're just continuing to clear. And this is something that I may have to actually consider when I go to machine this in a few days. But looking at the height of this tool, so this is a 1/4 inch tool. I'm not sure if we have any 1/4 inch tools in this length. So I might actually have to change this to like a 3/8 or something when I come down in here. So that way I make sure that the actual tool holder itself isn't smashing into this little nub. Yeah, let's keep going. So, yep, just as an adaptive. And now we're going to go through and we're just touching up everything. So now we're doing our final finishing passes, our radial finishing passes, our axial finishing passes. Keep going. And this is another spot. Like this gets really close. Or actually, no, it's not yet. Not yet. It was cap. Okay, finishing pass there. Not there yet. This guy right here, that contour that you just saw is actually a contour that I defined using a sketch. Remember, sketches are powerful. Yeah, let's keep going. A pocket on that thing. So yeah, this is what I was talking about. So depending on my tool setup, I really need to pay attention to the actual tool length, because if we don't have a very long flat end mill, 1/4 inch flat end mill, it might actually hit that nub. Continue. Another contour defined by sketch. You guys saw that one a few minutes ago. And then this guy. Oh, does the outer portion first. Gucci. And you'll notice. Ooh, this is interesting. Okay, very interesting that I caught this, but you'll notice that this looks a little weird. Okay, so what just happened is that tool, and I don't want to replay it just because it's going to be, the simulations can wig out sometimes, but this actually, when we roughed with the 1/2 inch, it wasn't able to get nice and deep into this fillet. So when we came with the contour, we actually are going to engage a ton of that tool, which has the potential to break the tool. So I just need to, I'll relook at it. I'll kind of do the math in my head, and I'll see if that's actually good moving forward. And if it is, then I'll keep it that way. And then we have a nice contour, and then we have our drilling. Now drilling, just some considerations. Make sure you're not running the same RPM as you are on the end mills. You want to be at like 500 or so RPM, whatever, depending on the tool. Look at a speeds and feeds table. Yeah, run those drills pretty slow when compared to the end mill. And I will go ahead and create a new setup, and I'm going to do some mining off camera, and I'll be back here in a sec. I know this video is getting pretty long. I know it's rough, but whatever. Okay, just wanted to touch up on this and creating your own origin. I'm going to go ahead and origin off of this circle. And I don't have, if I do that by going to selected point, but I don't have a point normally, but I actually used a sketch. I just did a project entities on this guy and then put this little point in the center of that. And that just allows me to select it. And just like before, we could select our Z-axis. Our X-axis is good. We'll flip X. We'll flip Z. Oops, no. Flip X again. Okay. And that is what I am talking about. So now we can origin off of that circle. And you'll note that because we flipped this part, we actually have, we still have material. Oh, shikaz. Huh. You know, I'll come back to you guys in a sec. I'm going to change some stuff. Okie dokie, I am back. Now, I did some interesting stuff. Now, you might be thinking to yourself, if you actually kind of know what you're doing, why don't you just take the origin off of this hole right here to get the most accurate? This is a 1/4 inch hole. Feeding the Heimer down into that, it's fine. I've done it before, but it can kind of wig out on like these like really tight radiuses. So I generally would like to go with the bigger hole. I mean, like 3/8 and up is pretty solid. But that being the case, let's go and see what I did. So I have this basically set up in 2 setups. So using sketches, I just did an origin on the top left, and I'm gonna go ahead and simulate that. So I use, oopsies. I use sketches to define my machining boundaries. Did an adaptive, and I did a pocket. So cool. That's all that happens in this operation. And what it does is it exposes this hole as well. It gives me a nice, the correct surface, because of course these still have stock to leave, the correct surface to actually, to Heimer off of in terms of my Z. So you get your X and Y from this hole, and then the Z from, basically any of this surface, this surface, this surface. I mean, that's all fine. The interesting thing about this is that because it's doing a finishing pass in its own way, not within like a singular operation, it's doing a pocket here. It's gonna look like everything else is gonna look uniform except this one spot. This will have like a different machining path, which will kind of be interesting to see. Doesn't really affect the part. It'll just look a little different. If you don't like it, you can hit it with some Scotch-Brite and really get out those machine marks. But machine marks kind of have a drip factor in their own sense. And just to clarify, some of the, like, you might notice, like, why didn't you just do the whole thing? Well, the most important thing about this is I need this to be concentric with this. And if I'm not, or if I'm just origing off a piece of, like, the corner of a stock, measuring the stock, you know, a lot of times you're measuring it with a ruler. We don't have any 12-inch calipers or anything. So if I machine this is going to be offset from this. And that is the only important tolerance that I care about in this entire piece. So that's just stuff to keep in mind. And a lot of this stuff you're probably going to have to learn in blood, honestly. So you might look at this stuff and be like, oh, why don't I just do this? I could take shortcuts here and there. And it's fine. You can do it. Your tolerances won't be the best, just, you know, just machine on your own. Not on your own, of course, with supervision. Machine and, you know, see what goes wrong. Stuff might happen. And, you know, there's a lot of attention to detail stuff that you really got to notice before you really start getting like really tight tolerance parts that come out perfect every time. But it's just these little lessons that you have to learn along the way that you're not going to be able to pick up every single one from this video. Okay, I'm going to finish this part up in its entirety, and then I'll come back and review it. Oh, sorry, I forgot to totally mention. The whole purpose of that was so that way I can get this origin off of it. Oh, I totally did mention that, but here's the setup anyways. Yeah. Okay, so I pretty much got this, not pretty much, this part is finished in terms of cam. I still need to go and do feeds and speeds. But first we're going to go through and do soft draws. That'll be the segment after this, but let's kind of go through the second setup. Nothing you haven't seen before. Now that we have an origin on our actual part itself, we know that it's going to be pretty accurate. Go through just adaptive clears, pockets. And if you remember, if you got a keen eye, you'll remember that the actual pocket toolpath on this was left to right as opposed to the up and down it's doing now. So that'll be kind of funny to see what it turns out to look like. So just the pocket to do the axial finishing pass. Remember, we can do axial finishing passes with the roughing end mill. Keep going. Boom. And now we're going to go back to the 1/4 inch. I did do a machining boundary here on the adaptive. Not really needed, to be honest, but whatever. I had the sketch there anyways. So machining boundary, clear out all that material. Keep going in. Again, I grouped my tools together. So we have tool 11 and tool 30. They're all grouped together. Go through, do our finishing passes, do this contour, do this tiny little, now it leaves a little material, just do a little tiny pocket, just a boop, and it just goes through, does some air cutting. Cool. Alrighty. So that's all that part done. And now for our final operation, we're going to go to our setup. And you'll see here that I actually origined off of this part right here. I just did a sketch on this face and then like lined it up with that. I just did a center point. You might be asking, why am I drilling from this side instead of this side? If you look on this side, we have a beautiful, beautiful flat surface that we can rest on the parallels. So that way, we're not getting any weird tipping. We're not getting any chatter. Well, we're not getting as much chatter because in this setup, parallels would be resting. We'd probably push the parallels as furthest as we can to the right until it engages that fillet. And then this would kind of be hanging in dead space. But what we can actually do is, in order to reduce the amount of chatter, is we can pull the parallels a little bit back. They'll be hanging, if it's a 6-inch vise, it'll hang out of the vise a little bit. So that way we get the vise around this face right here to really ensure that we have the least amount of chatter as possible. Chatter with drilling is not good. You can vibrate that puppy and it'll just snap the drill bit right off. It'll snap it real good, especially if it's carbide. I recommend tool steel like drill bits and stuff just because they're way more ductile. Less brittle carbide is really good in terms of remaining tolerances through like manufacturing tons and tons. You're drilling 1,000 holes with that thing, and the tolerance is really solid. We don't drill that many holes. Our tolerances are fine for our holes. It's good. So yeah. Oh yeah. And then last thing I wanted to point out is for the actual spot drilling itself. You'll notice that it just plucks just a little tip, and we just do that by controlling the heights tab. And that is it for this, you guys. So that is a general overview on operations, and I guess kind of the tool table. Just to cover everything, just a summary. You know, you guys kind of saw the setups already in the previous video. Hopefully you haven't forgotten everything from that. But for large cleaning operations, we use adaptives. That way we can control optimal load. And I'll be hitting up on all the optimal load stuff again and when we hit feeds and speeds. For finishing passes, axial finishing passes, we use pockets. That's going to be under the 2D section. And for radial finishing passes, we're going to be using contours. Sketches are super important in terms of retaining your machining boundary. Ensuring that your tool is going where you want. What else? Yeah, sketches. You constantly use those sketches. Here, let's see. I've got a total of, sometimes this is a pretty simple part. It's not crazy. It had a lot of little stuff. I wish there was a fillet somewhere, so that way, like an axial fillet that we could hit, so that way I can kind of show you guys what's happening. But you'll figure it out. Ask somebody, like I said, ask somebody who's more experienced. A total of 1, 2, 3, 4, 5, 6, 7. Yeah, 7 sketches. Wait, 1, 2, 3. Yeah, seven sketches because we're missing a sketch 5 here. Let's just kind of go through real quickly. So we had a sketch there. That was for a contour, just because it was mowing down this entire section. Let's go to our next sketch. Another contour here, as well as a machining boundary for our adaptive. This sketch here, that was for a 2D adaptive because I drilled it out. No. What was that sketch for? I don't know. I don't remember. And then where's this next sketch? Oh yeah, this sketch right here for the actual origin. So we can make sure that we're getting an accurate tolerance on this little peg here. We don't want to origin off the stock on the second operation. Super important. This sketch, a machining boundary for the adaptive to expose that origin, and then a pocket to expose the axial surface on that guy. And then this last one, just so that way I can select that for my origin. But this is definitely going to be the longest video in the series. Sorry it took so long. Watch it at 2 times speed. It'll still probably be on YouTube, so you have that capability. There's a lot of important lessons in here. If you sat around and watched the whole thing, congratulations. Hopefully you've picked up a few little niche tips here and there. But that is it. The next section will be soft draws. Hopefully that'll only be like a 10 to 15 minute video. Feeds and speeds will be really fast too. That'll probably be a 5-minute video. And then post-processing, that'll probably be like 2 minutes. So if you finish this, you're almost at the end. Alrighty guys, to the next one.